as we begin here, we are in Unit 1, Introduction of Physics. We're in the measurements and matter. And yesterday you did that. You made some measurements in the lab. So we're going to do some of the activity, go over some of that, and then we will come back. Like I said before, this is very cyclic. We will then come back and actually talk about some of the measurements, doing some conversions, and in a way, you did some of that converting at the end of one of your things last time. So, to study the properties, we need to make sure that we're making measurements, and that is just that. The measurements that are made, they, whether it be this many, this object balances out with that object, those are measurements. And making sure that we have good, accurate measurements. Now, yesterday, the lab that you did was not based on any type of system of measurement at all. Very simple, it was just measurements. So the scientific measurements that we like to make and that we will make eventually is the ones that are based on the metric system. The metric system can be expanded out into what is called the SI system. A lot of times people think of it as, oh, it's just the science system. No, it's actually the S and the I stand for System International, which means the international system of measurements. And so what we would look at is so that all scientists convert to a certain base unit. That's what the SI system is there. But a lot of the SI system is based on the metric system. Yesterday's measurements that you did in the classroom or that you took part in even virtually were rudimentary scales. You just saw whether or not the scale balanced back and forth in that teeter-totter. And so those measurements that we have are just that. They're measurements. And they didn't tell us a lot of information, but they told us enough that, this clothespin was balanced out by this many hex nuts. And so that is a measurement. It might not be a metric measurement. It might not be an SI measurement, but it is a measurement nonetheless. As I said before, the SI stands for System International, meaning it's an international system that is everybody agrees upon. The SI system has some different measurements as well. For base units, really, is what it comes down to. The metric system is based on 10. A lot of times students, don't always like the metric system, but I think the metric system is much easier at times to handle and deal with than, say, the standard, which is the inches, feet, and beyond, because the metric system doesn't use fractions. Now, not very many people enjoy adding, subtracting, multiplying, or dividing fractions, and that's what the metric system gets rid of. The metric system, because it's based on the factors of 10, it allows us to use decimals. Decimals is much easier to do a lot of the math that we want to do with. Okay, some of the metric systems, you convert some of the decimals into fractions if you have nice ones, but not all of them do very nicely. And then because like 11/30 seconds is not an easy thing to do some math with. You have to find the least common denominator. You have to, all these little parts need to be done with it. And so it's not always easy. And in science, we use a metric system. I will make references to basic other measurements, such as miles per hour, when we're talking about meters per second. That is done so that you have a connection between the metric system and the system that we use in the United States, and that is the kind of the standard system is what it's called. As some of you have probably worked on automobiles or in other areas where you have different size sockets for different size bolts and nuts because of the whole, you might have a 9/16 as opposed to a 13 millimeter. That's what the millimeter is, the metric, and that's why they're called metrics. It's pretty basic, almost self-explanatory even. But that connection in between the two is where that is. But ultimately, in science, the metric system is what we're going to use as we move forward. Yay! Some ways in which we can measure matter. The length or distance. In physics, that's what we use a lot. We're going to use lengths and distances quite often. Metered ends up being a real nice measurement. Half a meter also becomes very nicely because we can make some of those measurements as we need to, as some of that happens. Also, time is a big measurement as well that we tend to use frequently. And that allows us to get into some other stuff that we'll end up using. Temperature. We don't use that one in this class very much because temperature isn't one that we need to use. Amount of substance or number of particles, that's more of a chemistry measurement. Electric current is one that some of you probably have come to experience in your own life, in that you've had some electric current go through you. Not always the most fun and enjoyable time, but it's something that's there. Luminous intensity. I always find the label for luminous intensity to be quite interesting and almost very connected to what you're actually making a measurement of with that. But the ones that we are going to deal with the most, and the measurements that we really are going to look at, is length and distance, time, mass is also going to be a big one as well. And so these are going to be the big three measurements that we can take very frequently. There will be times that you would think that the mass or the amount of matter in an object matters a lot, but because of the way the equations work, that can be taken out. And so that mass doesn't always matter how an object moves because of how the equations work out and how the science works out for that as well. And so we do need to be careful about that. Now, some of these measurements, again, they have labels that go with them, and some of them are also used to do what are called, those are the basic units. These are called derived units. Volume is a derived unit from length. And so that is where that comes in from. Velocity, we are going to use velocity very, very frequently. Okay. Volume, a little bit. Velocity is one. And that is where that comes from. And a lot of you know the value that you need for, say, volume with the length times width times height. That can be done a little bit differently. The velocity is the equation of velocity is equal to distance divided by time. Density is mass and volume, and density is derived from, again, mass divided by volume. Some of those equations you will have probably might recognize from 9th grade physical science, whether you took that or last time you had some of those science classes that you took in either 9th grade or 8th grade. Density is one that is used quite frequently. We are going to calculate velocity a lot, and it's going to come probably very easy. It's going to be one of those calculations as we go through. One of the things that we're going to eventually get to you is something that is called an equation sheet. And those equation sheets are going to have a lot of these equations that we use for these derived measurements on them. As how we make a lot of these measurements out, a lot of you probably have, like I said, have done a lot of these. Length or any type of distance can be done with a ruler, meter stick, depending on what is being measured. Calipers can also be used as a means of measurement, depending on what kind of accuracy you want to have. A lot of us, like yesterday, the scale that we were using wasn't one that more of a balance type scale, and so we have that going on, and it is finding a mass, and the measurements again that you were making were just a little bit different. Time, a watch, and one of the things that we can utilize our iPads for is that it does have a stopwatch on it very easily. We also have some equipment that we will be able to use in the lab that is their kind of vernier software. It's some photo gates because some of the labs that we do require times and require equipment that might be too hard for a human to start and stop a stopwatch with a reasonable amount of accuracy and precision, and so the photo gates allow us to do that. And this vernier software is accurate enough to make very good measurements. If you were standing 2 meters away from a wall and you had one of these motion detectors on and you had it placed against your chest to just hold it steady, it will actually read your chest going in and out. And that is where we go with that. We want to make sure that we are making those measurements properly, and that's where we kind of that. Temperature is usually measured with a thermometer as we need to. Volume, again, we don't make that measurement in the classroom very often, for at least this classroom. And then the volume isn't used. That's more of a chemistry thing that we'll use as we move forward. And after using the meter sticks and the watches or the timer stopwatch on your iPad, you will be allowed to move forward and kind of get that data into other things and utilize that data more easily. These measurements that we make, like I said, they don't always match up. Some of them do, some of them do not. The measurement for length is just that, the meter. And the SI unit for length is also the meter. Now, this does not mean those are the only measurements that we use. That just means that is the basic unit that all scientists agree on, that would work. And we do have to convert or use other forms of this as well. So say an atom is extremely small. Using a meter to report it is something that we actually do, but sometimes to make the number more reasonable, we will use a prefix that is added onto that, such as pico or micro. That will change our understanding of how big or how small those items are. But the one that you really can see is that the gram is the base unit for the SI system, and for the SI system, it is actually the kilogram is what we end up using for it. The other parts that we will find is then that's why. It's like, why do we use that? Well, because measuring the weight of a celestial object probably doesn't make a lot of sense in using the gram. Instead, doing the measurement in kilograms makes a little bit more sense. Time per second is very simple because not everything should be measured in years or months, because sometimes in geology they have to use a much larger one, and that is eons. Eons is much larger of a time, and that's why they use eons, is just so that our brains can actually comprehend how the number. If I said 2 seconds, we'd be able to go, okay, 1, 2, and understand that that's there. If I said it took 2 eons for the Appalachian Mountains to form, you'd be like, okay, I know I've seen 2 of something, but eons is such a large portion of time, our brains don't actually really have a tough time understanding it. And that's why sometimes geology and the sciences can get a bad rap, is because we have these things that are for very large things, and or very small things, such as in chemistry, as we kind of move forward. Volume, and this is the one that ends up being another weird one. The metric unit is the liter. That's what a lot of us would know it as. But the SI unit is actually meters cubed, which is much larger than a liter. A liter is actually a decimeter cubed, which is like 10 centimeters. And so a meter cubed is actually a very large amount of volume. And that becomes, and you would think, to give you a rough guesstimation, like usually more of your standard washers and dryers are almost, with the outside, are almost a meter cubed. So that can be a very large thing. And why do we use volume for that? Is because we look at like volume of gases. Gases can take up a very large area. And sometimes that is why they kind of work with that. So again, these measurements don't always match up, and that's for many reasons. When we make these measurements, and especially in science and chemistry and in physics, it's important that we understand that these equations, that we're going to have some equations, we're going to have some things that might seem off, might seem there, but a lot of what we want to look at in this class isn't always just the math that's being done, but the why does the math work. And that comes from the concepts that we cover. The concepts that we cover help us understand which equation to use and how that connects to other aspects of this. Okay? And so the equations and the science have to go hand in hand. We're going to cover converting much more in the coming days, and because that's something that we have to do for the rest of the year here in physics, and is doing some converting. You will become good at it. In some ways, it's kind of forced upon you to try and get you to do these conversions in that manner, and that helps us put the equations together properly, so that the labels and the what we're and how we describe what we're actually measuring works out great. And that's where it guides our thinking, but it doesn't define our thinking, and we want to make sure that we are able to think and go through that.